Ready? Good afternoon. Thanks for joining us. Developers are required to deliver high-quality, feature-rich applications on tight timelines, while simultaneously staying up to date with the latest programming languages, frameworks, and tools. They're often juggling multiple tasks in parallel, like writing code, debugging code, testing it, deploying it, doing on-call work, all while working with their teammates as well. This can lead to a cognitive overload as well as really high switching costs as they work between those different tasks. Anyone experience that? Anyone? See a few heads. I know we have. We're here today to show you how Amazon Q developer agents can help you ship faster by removing that undifferentiated work and enabling you to focus on the more critical and crucial aspects of software development. My name's Doug Clausen. I'm a product manager with Amazon Q, and I'm joined by Jana Powell, the head of technology, research, and innovation at DTCC, as well as Manny Srinivasan, the senior manager of product with Amazon Q. Now, I'm going to start off by introducing Q before Jana's going to walk us through DTCC's adoption journey, including how they see these agents applying to their work. After that, I'm going to come back and talk about our vision for agents and how we see those agents working for you and helping you ship faster. And I'm also going to show an agent architecture of one of our current agents we've released today. After that, Manny's going to come up and give us an introduction into the brand new agents that were released just yesterday. Amazon Q Developer is a generative AI-powered assistant for software development. Q Developer has features across the SDLC, not only helping you build faster, but also operate and maintain your applications as well. Q Developer can generate real-time suggestions from your inline comments. And we've seen a number of customers who have drastically improved their ability to deliver with Amazon Q. Any Amazon Q users out there? Anybody used it? Good. But Amazon Q Developer is much bigger, much bigger than just inline completions or chat. We've also already released specialized agents to help you complete multi-step tasks as well. Now, before we dive into those agents, I want to first hear from Jana on their adoption journey with Amazon Q. So, Jana, over to you.
Thank you very much, Doug. Can everybody hear me?
Yeah.
OK, perfect. So I think first I'd like to start with a question. So I know we have a very diverse audience here, people from a bunch of different companies. So how many people are familiar with DTCC? Not that many people are familiar with DTCC. So let me tell you a little bit about DTCC. We are a central securities depository for the US. We essentially process and clear the large majority of securities within the US. So last year, we processed $3 quadrillion in securities. In fixed income alone, we processed $6 trillion worth of securities per day. That's $250 billion per hour. So it's a lot of responsibility. And DTCC, arguably, as one of the most financially regulated firms in the world, not surprisingly, highly values security, scalability, performance, and resiliency. So going fast and breaking things is absolutely not an option for us. So you can imagine risk mitigation will always be at the top of our list with respect to our core strategic pillars, but also our AI strategic pillars. But in addition, there's a lot of other goals that we have as well regarding our Gen AI use, such as transforming the client experience, optimizing productivity, and also advancing AI research and development. So a year ago, we established a backlog of about 400 Gen AI use cases that colleagues across DTCC wanted to pursue. And of these use cases, developer productivity scored really high, mostly because feasibility scored high, and so did potential impact to DTCC. So the goal was to test a developer productivity tool to determine whether we could substantially improve the efficacy and also achieve productivity gains for our developers. So the challenges that we faced at that time was that it was January 2024, and there were so many new developer tools just coming on board and being released. So several members of our board and our executive committee were just not convinced that the tools were going to be delivering the ROI expected. A reasonable assumption, especially given some of the early results. But they also were not convinced that the benefits were going to outweigh the risks of bringing on such new technology into our technology stack. So what we needed to do was we needed to prove really three things. One was that we could establish data-driven, measurable key performance metrics. Two, we could measure the results with the new tool over a robust historical baseline of data, which was actually hard to get. And three, show statistically significant evidence of success. And last but not least, we had to show that any tool that we would bring to DTCC would satisfy our non-functional requirements, which are pretty stringent around privacy and security. So we set up the parameters for the pilot, defining themes and defining the problem statement. And the problem statement was essentially, can a pair programming tool increase productivity with generative code? And we set measurable pilot objectives, including faster development, improving code quality, enhancing productivity, increasing innovation, and also enhancing collaboration. But before kicking off any efforts, we wanted to run an extensive tool assessment. And so we chose Amazon Q Developer, mostly over several players in the market, mostly because it achieved all of our requirements, the ones that were most important to us. So Amazon Q scored highest in security and privacy. It met all of our requirements for functions, for programming languages, for repository supported. It met customization requirements for training on code repositories, and it also had innovative feature releases like Java transformation, which was highly relevant for DTCC. So this is the high-level framework that we used to assess various tools. So there were several parameters that we used to look at each developer tool to ensure that it met DTCC requirements. And the three main categories were functional, non-functional, and market differentiators. So I won't go into everything, but the key functional requirements that we evaluated included types of functions and features supported, programming languages covered, repository compatibility, integrated development environment compatibility, and also modality or coding guidelines. The non-functional requirements that we explored were deployment options, security and privacy requirements such as telemetry data. So we wanted to make sure we could turn off the telemetry data if we needed to. We wanted to ensure that the code was not going to be shared with third parties. And also suggestion traceability was important, meaning that the tool would provide traceability of the sources for code suggestions and more. And finally, we assessed market differentiating features, which I had mentioned before. So ultimately, we designed the pilot to ensure that it was a representative sample of DTCC's squads, of our languages, of our IDEs as well. So 5 of our programming languages were represented. 2 of 4 of our primary IDEs were represented. And the Amazon Q Developer was provisioned over 30 developers, to over 30 developers and across 4 teams. And those teams were chosen, again, for their relative diversity in applications that they covered. We also ensured that the participants used the tool over a course of 17 weeks or 3 to 5 sprints. I'd be remiss to not mention that it's really important to win over the hearts and minds of participants and of leaders. So in order to set up the pilot for success, we made sure we did a couple of things. One was convincing the teams of the relative success of the pilot and the benefits of the pilot, which included acceleration of ongoing projects, improved developer experience, and also having just the first mover advantage at DTCC of using new technology, which was pretty exciting at the time. We also ensured that each team had sufficient training on the tool, and we also promised that we would capture rich historical data from the participant teams to build that historical baseline upon which we would measure the success. And that was something they needed for reporting anyway. And finally, we stressed to the team that this is not going to disrupt their day-to-day work. They were meant to do their work business as usual, and that the more they use the tool, the more they would want to use the tool. So finally, how did we measure success? Success criteria is up in the right-hand corner. We had 3 metrics: efficiency, quality, and experience. And underneath the 3 metric categories, we measured for efficiency, throughput, pull requests, and build failure rate. Under quality, we measured code vulnerabilities, bugs, and test coverage. And under experience, we leveraged qualitative surveys to assess developer satisfaction and productivity perception. And we were able also to capture this data with tools that we already had. So TLDR, the pilot was highly successful. It was really exciting for us. It was really exciting for the developer teams. Essentially, we saw an average of 40% increase in throughput per participant. So what does this mean? Something that took developers 10 hours to do now takes 6 hours to do. We saw an increase in code quality and maturity assessment across the code repositories in scope. Build failure rate and test coverage remained stable. And finally, we saw an average of 30% reduction in code defects. So how did we measure this? Again, our board and executive committee really stressed this needs to be statistically significant. So we wanted to prove statistical significance. And what this chart shows is the observed average difference in throughput between participants during the pilot and also the baseline periods. So the green plot actually shows sort of business as usual. It represents the difference of throughput means likely to be observed between baseline and pilot if each experiment were run many times under what we call the null hypothesis or no effects seen. So green is business as usual. The orange plot shows the distribution of differences likely to be observed based on the observed metrics during the pilot. So when we measured the statistical difference, the t-test measurement, it indicated that the difference in the means between the pilot and baseline distributions is in fact statistically significant. In fact, it showed half a standard deviation of difference. So that indicates that Amazon Q Developer does have a positive effect on throughput with a high level of statistical confidence. We measured next code quality maturity assessment, that's CQMA. It remains stable with Amazon Q Developer, and these are the charts to the right. The chart to the upper right is the average enterprise CQMA score. And you can see that we introduced the tool in Q1 2024. That's indicated by the blue line going across both of the charts. And you can see that the average CQMA increased by approximately 5 percentage points as the tool was introduced. So CQMA is measured by 3 metrics. They're described at the left. One is code coverage quality. That evaluates the extent of the automated test coverage. The next is code complexity, and that assesses structural complexity of the code. And the third is code security, free and open source software. So that reviews the security of the open source components used in the code. And we also assessed build failure rates. So both of these remained in normal range, unaffected by the developer tool. What is build failure rate? It essentially indicates the frequency of issues in code integration and testing, and that can serve as an indicator of code quality. These metrics include checking the code syntax. It includes internal logic, looking for missing dependencies or typos. And the fluctuations we saw during the pilot were not statistically significant at the time, and that led us to the conclusion that Amazon Q Developer has no effect on build failures. There was one large fluctuation you can see in the green. That was indicated by just an anomaly in our ITP settlement instruction manager, not related to the development tool. Code coverage is on the bottom, the chart on the bottom right. That measures the extent to which the automated tests covered the code base. And that would ensure that the more code that's tested for defects lead to higher quality software. So the fluctuations in code coverage during the pilot were also not significant. And finally, for the qualitative feedback, the more fun part. So we heard significant praise about Q Developer from the pilot, from participants who had taken such a long time to fully adopt the tool. It really was a journey. These teams of developers, they were facing daily challenges, understanding complex code, writing unit tests, and refactoring and so on. But they became more and more attached to the tool. The more they used the tool, the more they genuinely wanted to use it. So developers had praised the ability of Amazon Q Developer to explain blocks of code just in plain English, making it easier to understand and work with legacy environments. One developer actually said, "Q has changed my life." So the tool's ability to just to really make developers' lives easier was so apparent. So it assisted with code refactoring. That was not necessarily logged in our story points and thus didn't show up in our throughput assessment, but it was still cited as a highly valuable feature. It wasn't just about the numbers, it was about improving the workflow for the developers. So another developer had noted, Q is helpful with code refactoring and unit testing. Looking forward to explore more. The Q&A chat feature was also highly valuable. It enabled a lot of self-learning. It enabled reducing the strain on senior developers and fostering a culture of continuous improvement. So one of the quotes we got was, "Q has removed the dependency on more tenured engineers for assistance." And that saves the time of not only the junior developer, but also the senior developer. Our Python team really found value in the inline code generation capabilities. So some teams had a challenge with this in that there were dependencies on code context elsewhere in the legacy code database, but some simpler tasks were highly addressable. So another developer had said, "Q reduced the time it takes me to understand and solve problems." So as we look into the future, there's a lot of things obviously that need to improve, but so many amazingly positive things that our developers are already seeing now. So with project level contextualization, that's only going to increase the value, making the tool a more powerful tool. And the journey doesn't end here, obviously. The more human in the loop development remains essential, and that's going to ensure that our developers continue to innovate and excel. So then, what was the next thing that we needed to do? We needed to show real ROI. And that ROI was based on the data that we found. And so to do this, we made a few assumptions, and we made sure that it was a conservative set of assumptions. So out of approximately 2,000 hours worked per developer, we assumed approximately 50% of the time developers are coding. And conservatively, we estimated a 10 to 20% productivity boost versus the 40% that we saw in the pilot throughput assessment. And then from there, we applied the annual cost per FTE less the annual Q cost per developer to get the net annual value generated per developer. So if we were to extrapolate to a much larger population, say 1,500 developers, what does that mean? What does that mean for DTCC? It's essentially an increase in productivity time of about 150,000 to 300,000 hours of additional productivity per year. And I should also mention this was just with the Q&A feature and the inline code generation, right? So we would assume that the estimate could potentially increase as Q releases new features. And so ultimately, the value story was crystal clear. We did get full approval to roll out the tool, and we're in the process of rolling out the tool across our developer population. Really excited about that. So in parallel, at DTCC, we're extremely excited about going into 2025. We're excited about agentic frameworks. We're excited about all of the different pain points and challenges that we're still trying to solve. So among a few of the areas that we believe we're going to see significant efficiencies in our Java version upgrades, specifically the Java version upgrade from Java 8 to Java 17. That's hugely relevant to DTCC. Unit test generation is also a really interesting area for us. Writing comprehensive unit tests is essential, but it's also very labor intensive. Code comprehension is another area of focus for us, and documenting technical specifications and release notes just requires meticulous attention to detail. And finally, code reviews, and specifically scanning code vulnerabilities and identifying and upgrading older libraries. So you're going to hear a lot about what AWS is doing with agents that really can address a lot of these problems. So Our hypothesis is that incorporating AI agents into these areas not only accelerates development processes, but also is going to enhance the overall quality and security of our code base. So thanks so much for joining me on this. This has been an amazing journey, and AWS has been such an amazing partner. So I'm going to hand it over to Doug now, who's going to walk us through more details about AI agents.
Cool. Thanks, Shauna. It's really fascinating to me to see DTCC's adoption journey. We often hear from customers about calculating ROI and how do they know they're getting the benefit that they want. You saw DTCC take a very scientific approach to this problem, which is what you expected. It's Dr. Jana, as you saw. They got a baseline, they measured against the baseline, and they drove their decision with data. They're just getting started with the agents, and that's a typical adoption pattern that we see among customers. They start with high-touch features like a chat or an inline completion, where they build some confidence in Q and how it works before they start exploring some of the more advanced features that we have, like the agent capabilities, and I'm excited to see where the agents take them. Now, before we dive into the agents that we launched here just at re:Invent, I want to take a step back and first walk you through how we see the Q agents working in the future. We hear a lot of talk in the industry right now about agents or agentic capabilities. And because this is a pitch on generative AI, I didn't get a person quote. I got a quote from Claude 3.5 Sonnet to define an AI agent for us. So an agent is a software program or system that perceives its environment through input data, makes decisions through some decision-making model or logic, and then takes action to achieve its design goals or objectives. And we'd add one more thing to this. We also think that they'll learn from what they do. Let me take a non-software example real quick to talk about how these agents may work. Now, most of us here in re:Invent are staying at a hotel, right? When you booked that hotel, you selected the dates that you wanted, the type of room you wanted, and the system looked at the environment, in this case, the hotel's availability, and returned you a list of options. You then decided if you wanted the cheapest room, or maybe you want to pay a little more and be closer to the Venetian. You selected the option that you wanted, and you booked your room. However, as we know, the environment changes over time. And so as supply and demand of the hotel availability changes, you could possibly get a better rate at a better hotel closer to the Venetian. And so you might find yourself, I know I did a couple of times, looking at rooms again and see if I can get a better deal. Now instead, imagine you gave an agent a goal. You want the cheapest option that's 15 minutes from the walk to the Venetian. You like Hilton hotels, king beds, and you're willing to spend $300 a night. Anything else, you want to manually approve it. Now in this case, the agent knows the goal, it knows the environment, it knows when it needs to ask for help, and it knows what it can do to reason and make decisions about what you've asked for. So you set it off, and it finds you the best option. Again, we've talked about the environment can change, so as that environment changes over time, the agent could potentially rebook you multiple times without you having to do anything until you find yourself inside your cancellation window and you have your room here at re:Invent. Also, as you continue to use this agent more and more, it would learn from your behaviors. And so as it begins to, it'll get better at getting what you want at the price that you want to pay. So we see the software agents working in a very similar pattern, with a known goal or objective, the ability to reason and make decisions, and an understanding of the environment. Now let me walk you through our vision for agents inside of Q. Let's start with the environment. When we talk about the environment that the agents will sense and interact with, we're talking about the entire software development process and really everything that surrounds it. At the core, the environment encompasses our code repositories, where the agents have access to the source code and commit histories of our projects. This allows them to comprehend the code base, identify potential areas for improvement, and even propose changes or optimizations. But the environment extends far beyond just our code. It also includes our project management tools and issue trackers and documentation. This gives the agent the tasks or goals to seek, helps them understand the requirements or the user stories, and the context surrounding those tasks or goals. The agents also have visibility into our CI/CD pipelines, which enables them to monitor build processes, see test results, and potential deployment statuses. This visibility ensures that if something were to go wrong, the agent would be able to see it and fix the part of the process that broke. External data sources across this lifecycle, things like industry best practices or your coding standards or security guidelines, are also part of the environment, and ensuring that the agents will validate their output versus those established norms and ensure any compliance requirements that you would have. The The environment also includes the application and infrastructure itself. The agents have visibility into the performance and scalability and health of our applications. They can ingest metrics from services like CloudWatch, gaining insights into, say, latencies or error rates. And this information allows them to identify bottlenecks and even potentially anticipate issues before they occur. For example, an agent could detect a spike in latency and automatically roll you back to the previously known safe version. After addressing the immediate problem, the agent could find the particular deployment which was troublesome, see the commits that went into that deployment, and then task another agent specialized in software development to make an update and redeploy to fix that problem. The environment is really a collection of things that the agent uses, whether as part of its knowledge base or as a feedback mechanism that is making changes. Now, as we've discussed, the agent operates on this environment. Now, I also want to call out that Q has access to the things in the environment today through features like chat, where you can chat about your AWS resources or chat about your code. However, chat's not always the best modality to solve every problem, especially one that's very task or goal-oriented, where an agent could help. And this is where agents can come in, helping us build and ship faster. Agents would add additional automation and automatic course correction, and you simply assign the task to the agent and let it work. For example, if I'm trying to add a new feature to my application, I could chat with Q about those changes. Then I could make those changes myself, and I could build it and test it and then deploy it. Or using an agent, the agent would do that for me, providing me back a solution where the agent's doing the writing, the building, the testing, the deploying, and then I'm getting the solution back. Now, we see inside the agent itself, the agent taking 4 pretty distinct steps. First, they sense the environment, continuously monitoring and gathering information. This step involves perceiving and comprehending the current state of the environment and being knowledgeable about the environment in general. Next, the agents will act with a particular goal or a task in mind, and based on that sensed information from the environment, the agent decides on the appropriate actions to take to seek that goal or solve that task. These actions could range from generating code to suggesting refactorings or even proposing architectural changes to your running application. Now, once the agent executes those selected actions, it moves to the next step, where it observes the effect of the action on the environment. Now, this step could involve monitoring code quality metrics or test results or performance indicators or really any other relevant feedback mechanism that exists inside the environment. In this step, the agents will evaluate whether the actions they took had the desired effect or if additional changes are still necessary. Finally, the agents will continuously learn from the observed effect of their actions. They'll refine their decision-making processes, they'll update their knowledge bases, and they'll adapt their behavior based on their real-world outcomes. This learning loop will ensure that the agent will continuously improve and tailor their changes to your specific context or your specific project. Now, learning is what we really feel like sets these agents apart, especially as compared to other modalities. Now, this 4-step cycle will operate as an infinite loop, where agents are continuously sensing, acting, observing, and learning. This essentially turns us into an optimization problem for the agents. Now, while a single agent is already going to be really helpful, we're really excited about the collaboration of multiple agents working on a common goal with a developer. Now, that's depicted here. Here we have specialized agents working together with that developer towards a common goal. Some of these agents might focus on requirements gathering and analysis by looking at customer feedback and tasking other agents to address that feedback. Those coding agents would generate code and simultaneously validate them against their knowledge base to ensure that the coding standards are being met. And this extends beyond the build phase as well, as we've talked about, into operations, with agents specialized in operating and maintaining your application, helping you root cause problems when they occur and then getting them fixed. Now, we see these agents running both semi-autonomously and fully autonomously. Today, they're mostly semi-autonomous. In a semi-autonomous mode, the agent's working more like a pair programmer. For example, if I'm working on a UX, maybe an agent goes off and comes back and gives me 3 or 4 different designs, and I can choose which one I want to head down the path with. Fully autonomous agents would be different. They'll know their goal, and they will work independently to achieve it. Now, we believe this future with agents is closer to reality, especially as the underlying technology continues to rapidly mature. And now, with this vision in mind, we released our first 2 agents in GA earlier this year. The first agent was for code transformations. This agent allows teams to seamlessly upgrade their applications from Java 8 or 11 to version 17. It's what Jana called out and being excited about. As you may know, here at Amazon, we use Java. A lot. It's everywhere. We've already migrated tens of thousands of production applications with this agent, and we've estimated that we've saved years of development time and performance improvements worth millions of dollars per year. We also released an agent for the build phase, helping you create your applications. Using natural language input into problem statement and your project context, this agent will autonomously implement multi-file features and bug fixes. And we've also seen some interesting use cases here with customers using this agent in a business requirements document to get an entirely running application, or sometimes just updating an API or creating a website. Now I'm going to dive a bit deeper on this agent and show you how it works today. So here we are back to a very similar picture to what we showed with our vision. In this case, I'm going to talk specifically to how the software agent's working today. It currently uses the source code repository for context, it observes it, and it takes actions on it. This agent starts with the user providing a problem statement in the form of natural language. Then the agent will work to solve the problem while providing the user an explanation of its actions as it continues, as it progresses. Inside the agent itself, today, it's working much like a developer, but it uses a text-based IDE more akin to machine-to-machine interactions. It first selects a tool. Today, the agent's equipped with tools to explore files, search files, modify files, add or remove files, or undo its previous change. After tool selection, it uses the tool on the environment and observes the output. The agent then repeats this loop until it believes it's converged on the solution to the original problem. Once it's converged, it returns the updated code to the user for review and exits the loop. While the agent isn't learning today in its current form, we are exploring the best way to make that a reality. We're also adding more tools to its toolbox, allowing it to do more to solve the problem, and expanding on the types of things it uses from the environment to solve the problem. Now, the results of these efforts have been really promising, and Q Developer Agent is again in the #1 spot on the SWE Bench Verified benchmark, if you're familiar with that one, with the Q Developer Agent today independently solving around 55% of those problems. Let me now jump into a quick demo to see how this development agent works. So here I have a voting application. It's very simple. I have these API endpoints. And when you hit these endpoints on these restaurants, it increments a counter in DynamoDB. So I have Outback, I have IHOP, and then my kid's favorite, Chipotle. So let's go ahead and run it, and we'll see what it looks like. So here I'm going to hit the Chipotle endpoint a few times, and you're going to see the counter increments. Right? So pretty simple, incrementing the DynamoDB count. I also have a list of the APIs available, and then I have a very rudimentary Git votes, which just shows you how many votes each of the restaurant has. Now, I want to add a front end to this because it doesn't really have one, and I want to allow a user to vote. I'm going to use the Q Developer Agent to do that, and I'll go into the Q chat. I'll type /dev into the chat box, and then I'm going to ask for a new route at /votes. I want a password-protected page, and I want to return a table with the restaurants, their current votes, and then give me a way to vote for those restaurants. So I fast-forwarded this part. It took about 2 minutes. And it's giving real-time updates throughout. We're just going to look at the updates at the end. But we can see here it's reviewed our app.py. It has created a new template for us to use. And then it's also already made the changes to our app. OK, let's see what it did. So it starts off by opening our file and trying to understand how we want to implement this. Before it then implements the voting route, it creates an HTML template to use in that voting route, adds the password protection, and then, nice of it, it even fixed some improper indentations that I had done. So appreciate that. And then I also get this code back as a format of a diff, right? So I can go and see what it actually did here in the code as well. So here I have a new function for the authentication. We could make this a little bit more secure, obviously. It set the admin password to the famous admin. Or it pulls it from an environment variable. It did the environment variables because we did that in other spots of this app. It created a getsAllVote function, and then it creates our new route at /votes. And includes some error checking as well. Now, opposed to looking at the votes.html template, let's just accept the changes, which will put it in my local IDE here, and I can run it again and see what it looks like. And now we can navigate to that /votes page, which now should exist. We get our login with admin and admin. Don't tell anyone. And then I have my table here, which is exactly what I asked for, right? I have a table of the restaurants, I have the current votes, and then I have actions to vote for each of them. Now, if I decided I didn't like this, I could now iterate with the agent and tell it what I don't like. Maybe I forgot a requirement. Maybe I only wanted someone to be able to vote one time. I could say, only allow people to vote one time, and it would iterate on the code again. Or I could take these changes myself, and if I think I'm close enough, I can just do it myself and finish the job, right? So this is our Q developer agent for software development. Again, you invoke it by using /dev inside the Q chat. And so with that, now I'm going to pass it off to Manny, who's going to talk through some of the exciting new agent releases we just made at reInvent yesterday. Manny?
Thanks. Pretty insightful, Doug. With that in mind, let's talk about what's next for Amazon Q developer agents. At reInvent yesterday, we made 3 new announcements for software development agents within Amazon Q developer, and we're going to touch upon them here. The first one that I want to talk about is Amazon Q developer for automating unit test generation. One of the common feedback that we've heard from our customers and developers is that once they write a particular, address a particular issue, write an enhancement, create a new feature, that the next thing that they need to do is to write unit tests. We all know how time-consuming and tedious writing unit tests are, but we also realize how critical they are. To solve for this, we are incredibly happy to announce Q developer agent to automate unit tests. Similar to /dev that Doug just showed, the entry point for this is going to be /test, which we will show pretty shortly. And through this particular feature, we believe that we're going to reduce a lot of developer time and effort in terms of writing unit tests. It's also going to make sure that the code that you're actually going to ship is going to be more reliable with better unit test coverage. So let's see a demo of how that works. So here I am going to go ahead and use the same application that Doug used. And here I'm going to, instead of using the /dev that he referred to, I'm going to invoke the /test command. And in this one, I'm going to go ahead and write a natural language prompt here to say generate unit tests for a getBooks function. So this is something typically that developers would have to do manually. So instead of that, you can assign this particular task to Amazon Q developer. And what Q developer is going to do is it's going to understand the context of what you're trying to do. In this case, it's going to say, I'm going to generate unit tests for getVotes in app.py, and it's going to start synthesizing what it needs to do to generate the respective unit tests for this. So within a few minutes, you're going to see the unit tests being automatically generated for you. And as a developer, you can click on a view diff. So if unit test file exists for this particular project, it's going to add it to the existing file. If one doesn't exist, it's going to create a brand new file for you, which is the test file that just created. It creates all the positive and negative test cases that are required, whether it's passing the right restaurants, what if you pass invalid restaurants and such. All these things are going to be completely automated for you without you having to do anything. Pretty cool, isn't it? All right. So that's the first feature. The second agent that we are thrilled to launch is the Amazon Q developer for automating documentation. So let's assume that you use /dev and you use /test. You've created all the code that is required. You've written all the unit tests. What's the next favorite activity that all developers have to do? Just to write documentation, right? When as a developer, I enjoyed writing documentation. Well, either way, so this is going to be solved by using Amazon Q developer, right? So what it's going to do is to generate automated documentation for you. And the documentation that we are talking about in this particular case is generating READMEs or updating READMEs. And it's going to make sure that it's going to automate the entire process of writing documentation. So with this, we again believe that it's going to go ahead and automate all the workflows that developers had to do manually. Amazon Q developer agent for documentation is automatically going to streamline this for you. So let's see a demo of how that works. Here, it's the same workflow. So you're going to use /doc instead of /dev or /test. And here, I have an option, and we're going to guide the customers through this, right? Either you have an option to create a brand new README or update an existing README. So in this case, just for demonstration purposes, I'm going to say, create a new README for me. Right? And what it is going to do behind the scenes is it does the same thing, what it did for /test. It's going to understand your project structure. It's going to understand what changes have been made. And this is applicable for either brand new projects that you're creating or incremental updates that you've actually done. It's going to understand all the context behind it. It's going to create what we call as a repo map. A repo map is essentially think of it as a skeleton that has all the logical entities of how your source code is constructed. It's going to go ahead and understand what the repo map is. And this particular stuff is super critical for us to generate documentation. So in a few minutes, as you can see, a README has been indeed generated. And as developers do, I'm going to accept it. Please don't do that. But anyways, let's go ahead and accept the changes. And here you see what the documentation has been generated for me. It's a restaurant voting app. It's based on AWS App Runner and DynamoDB. It talks about the description of what this particular application is. It talks about, OK, it implements a restaurant function voting system. Seems right to me. It has got other bells and whistles, such as repository structure, how to use the application here, talks about the configuration, talks about what the API endpoints and such. And it's also going to go ahead and create a data flow diagram for me that kind of explains what the particular architecture is going to look like. Now, as a developer, I can accept this change, or if I want to make some more updates, and let's assume that I want more samples for the API pieces, I can instruct QDevelop to say, OK, write me more documentation pertinent to this API, give me some examples. It's going to automatically understand the structure, and it's going to generate documentation for me. So we strongly believe that it's going to save developers a lot of time. The final agentic feature that I wanted to talk about was to automate code reviews, right? So once we do everything, we've written documentation and such, that the next thing that developers need to do is to submit their code for code reviews. And we all know as developers how time-consuming and how back and forth code reviews are, right? As a code author, I have to submit the code. Then I have to wait for the code reviewer to say, OK, here are the 10 things that you should do properly. And now as a developer, I need to go back, fix the code, submit it back. And this is basically a loop that goes on and on. What if there was some sort of capability that will automate this code review process for me even before I commit the code, which is what we've done exactly. So we are very thrilled to announce automated code review agentic capability that's going to detect issues for you prior to you submitting the code, whether it is SAST issues, SEA issues, whether it is code quality issues, like whether you've written suboptimal code, or maybe you've chosen the wrong data structure, or you might actually written a function multiple times and there is duplication in the code. All these things will be detected for you. And at a click of a button, you can also generate code fix right from within the Q developer itself. So it's going to save lots of time and make sure that the code that you're going to commit to for code review process is already of higher quality. Let's see how this works. Here, as you can see, the theme is going to be the same. I'm going to say /review here. And in this particular case, I'm going to go ahead, and you have multiple options. You have an option to do the code review for the entire workspace that you're doing, or for the specific file that you're currently authoring. So in this workflow, it's going to do the same thing. It's going to look at your particular code. It's going to go ahead and do scanning, and it's going to go ahead and find out all the issues that exist in your code. And you can see on the left-hand side, it's going to start showing you based on the criticality, high, and all that stuff. And as a developer, I can actually look at a specific issue. I can drill into that on the right-hand side. And as you can see, you can hit the generate code fix, and then it generates the code for you. And then you can go ahead and accept this code. And this particular change, it's basically an improper resource exposure. It's asking you to go ahead and change the IPs here so that you are protected. Here is another example of inadequate error handling. I'm just here to show different capabilities of what it does. So in this case, there is no error handling that is put in place. So as a developer, I can go ahead and say, OK, generate a code fix for me. It's going to go ahead and give me a try catch and an exception here. And it's going to go ahead and make sure that the code that I'm going to commit to is having proper bells and whistles. Similar examples, like when you have a CloudFormation template, if you want to go ahead and make sure that you have proper CloudWatch alarms, it's going to go ahead and say, you don't have any kind of actions that are there. Why don't you actually create an action for me? So as a developer, I can go ahead, and the theme goes on and on. If you have package vulnerabilities, it's going to detect the package vulnerabilities for me. It's going to tell me what I need to do to solve this problem. As you can see that it's going to go ahead and remove a lot of manual back and forth that developers have to do, or try to figure out how to actually create that particular code for the vulnerability that Q developer detected. It's automatically going to go ahead and fix these issues for me. So with all these three agentic capabilities that we launch, another feedback that we got from our customers is, and by the way, all the demos that I demonstrated was in the IDE as the modality, right? Our customers have said, can you make all these capabilities available within my DevSecOps platform? And we are thrilled to announce the preview of GitLab Duo with Amazon Q. So all the agentic workflows that Doug spoke about, like /dev, /transform, /test, /review, all these capabilities are going to be available right within the GitLab interface itself, so that as developers, you can go ahead and see what needs to be done and make necessary remediations. And it's available in self-managed and ultimate subscription tiers. So let's see a demo of how that works. So this is the GitLab interface here, and I am going to go ahead and create a brand new issue. And in this particular case, I'm going to go ahead and assign, oops. Okay, let's see if this works. There you go. Well, technical difficulties. All right, so I just created a new issue here. And I'm going to, instead of assigning it to a developer, I'm going to go ahead and assign it to Amazon Q. And in this case, I'm going to tell to Amazon Q Dev, which is the agentic software development feature, to go ahead and create the necessary code for the particular issue that I just asked for. So what it is going to do is the similar capability. It's going to think, it's going to look at your environment, it's going to understand what you're trying to do, and it's going to go ahead and add a new sign-up workflow for my particular website right from within GitLab itself. I, as a developer, don't need to go back and forth multiple places. So it's going to look at it, it's going to go ahead and generate all the necessary code and artifacts that are required for a particular issue that needs to be solved. Now, as a developer, I can look at it, I can start interacting with Q directly from within this interface. So in this particular case, I'm going to say to Q to add more logging, and I'm going to assign it to QDev. And as you can expect, and it's a demo, so it's going to work. So it's going to go ahead and generate the necessary code for me with all the logging constructs that are required, and it's going to go ahead and create a code that is merge ready for me, and that's basically how we roll. So we are very, very thrilled with this. We've done a preview with multiple customers. They've all loved this particular capability. We look forward to doing more things. Here is another example of doing a code review within GitLab as a part of the merge request. You can go ahead and do a code review from right within this. So think of this as, instead of a senior developer having to do code reviews, what if Q can become the first code reviewer, right? So in this particular case, I have asked you to go ahead and generate, find out what issues exist. And in this particular case, I have hard-coded usernames. It's saying, like, go ahead and use parameterized prepared statements in this particular case. I'm going to say, all right, I don't know how to do it, so let me ask you to solve this problem. I'm going to invoke the Q fix feature, and I'm going to go ahead and get a code that is going to solve this particular problem for me. So you can see here, instead of hard coding the username and user IDs and all that stuff, it's using parameterized statements to solve this problem. So as you can see, it's going to be extremely simple for developers to interact with Q, the agents that we just launched, right? Whether they are using their IDs or within their GitLab interface, they can go ahead and do all the things that I just talked about. Now that we've actually spoken about all the agents that we just launched, I want to just spend a little bit time to talk about how these agents are going to work together, right? So currently think of these agents, and I always talk to my friends and I say these are all Lego blocks. Actually, not my friends, my colleagues. I say that these are all Lego blocks, right? And these Lego blocks, my friends don't care. I think of these as Lego blocks here, and as developers, you can invoke a specific Lego block to solve a particular problem, as I demonstrated earlier. Like, I can invoke /dev, /test, /transform, /review, and so on and so forth. But the way we are actually thinking about this, these agents are going to talk to each other, and they're going to work with each other very well. So think of assigning a developer task like creating an application, assign it to Q. Q is going to generate the code for me, and the next thing it's going to do is I need to write unit tests, because developers don't like writing unit tests. So I'm going to invoke the test agent and automatically create unit tests for me. While at it, I'm also going to create the documentation. So this is something that the agents will start to do, understand the environment, and it's going to start doing all these activities on your behalf without having you to go to multiple Lego blocks and interface. That's essentially the direction that we are actually thinking about. And that's the way it's going to go. So now that you have an understanding of what Q developer software development agents are, what it does, and where the vision is, here are some of the best practices that I want you to take away with. As Jonah said, like, start with a particular use case in mind. It's very, very easy to boil the ocean and say, I'm going to onboard tens of teams, I'm going to do hundreds of use cases. It's tempting to do it, but start small. Like start with a particular use case in mind. Practice makes everybody perfect. So make sure that you use software development agent as a part of your daily workflows, because then you will start to understand what Q developer agents can do for you, and that's going to make your life a lot more simpler and easier. And as with Q developer agents, agents aren't developers. They are not here to substitute developers. They are here to help developers, right? So make sure that every code that's been generated by Q developer agents, in this particular case, make sure you test them, you validate them, not the unit test, but just make sure that you test everything and make sure that you commit the code with full confidence. And finally, measure, and measure, right? It's without measurement, you cannot really understand what is happening behind the scenes. So that's also going to be important for your organization to understand how Q developer is going to, what kind of ROIs are you going to get by using Q developer or the agents. So with that in mind, I'm going to have a few call to actions here. Go ahead and install Q developer extension. If you haven't done it, please go ahead and do so. Explore all the agentic capabilities that I just articulated, and let's go and build some awesome software. So with that in mind, I'm going to say thank you. We're going to be here, and we're going to answer any questions. So we'll be on the side, and that's the end of this presentation. Thank you.